In this video, we will continue with the part 4, which is the integration by part. In the integration by part method is a very important technique in integration where you will have some problem that can be solved by using this formula. So this is the derivation for the integration by part formula. The origin, you have a product of two functions, fx multiplied with gx. So if you take the differentiation, you can use the product rule where we make the fx constant, okay, we differentiate the dx, plus we make the gs constant and we differentiate the fx. Then we integrate both sides, where you can get this answer. And then we rearrange the formula. So we put this term to the left hand side, this term. This is the proof for the integration by part formula. So to prove this, first of all, you can see that we have two functions multiplied together, fx multiplied with gx. If we take the differentiation of this function, we need to use the product rule. So fx constant, then we differentiate the gx, gx constant, then we differentiate the fx. So this is the product rule. Next, we integrate both sides. Okay, so you integrate both sides with respect to dx. Okay, dx. So this term can be cancelled, therefore you can get fg only. So we continue. We can rearrange the formula. Let us move the gx f prime to our left hand side. So you can have fg, which is this term, minus with gx f prime x, which is this term. Right? So let us make some substitution here. Let u to be fx, du is the differentiation of f prime x, v is gx, dv is the g prime x multiplied dx. So we substitute inside. So this term you get u, fx you get u. Okay, gx is the v, so this is v. G prime x is dv. Right. So this whole term is dv. F prime x is du. Therefore, you get the formula uv minus v du. So this derivation shows you that if you found two functions multiplied together in this relationship, okay, fx multiplied with g prime x, then you can use the integration by part to solve this problem. In this slide, it shows you how to select the u and dv for the general integration by part. So let's say you have something like this, u, dv. Normally, we choose the u where it can be easy for us to differentiate because we want to have du, right? So you have to choose something easy to differentiate. So on the other hand, for the dv, okay, you have to choose for the function easier to integrate. Where you integrate it, you get v. Let's say for log, okay, let's say we have a ln x here. So if you differentiate ln x, it will be much easier. For example, let u equal to ln x, and your du over dx will be just equal to 1 over x. Okay. Normally we wouldn't choose dv for log function. Okay, let's say you choose dv for the ln x, and you have to find the v here by using the integration. You have to integrate ln x. So you can see that inverse of inversion function is not that straightforward. Okay, you can see that integration ln x by using the inverse rule. Okay, you can apply the method and then get the answer in this form. Okay, so therefore, for log problem, by using the integration by part, we prefer to choose it, okay, as u instead of dv because it's very difficult to integrate. So as you can see here, it's very difficult to integrate. So as a rule of thumb, if you see inverse function like log or inverse trigonometric function, right? So this inverse function is very difficult for you to integrate. Then we choose it to be u if you want to apply the integration by part method. And the rest function, you can choose the dv. Let's solve the example 1a. So if you look at this problem, you have a function x multiplied with the sine x. So the easiest strategy that we have learned so far is the best integration rule. However, in this case, we cannot solve it directly. So we have to find a way, okay, to reduce to where we can apply the best integration rule. Okay, but it's quite difficult. No identity can be applied here. So product of two basic functions, okay, this is what you can observe. It's a function x multiplied with sine x, polynomial multiplied with the trigonometric function. So in this case, we can use the integration by part. So for the integration by part, you have to choose u dv equal to uv minus v du. So in this case, let's say we choose the u equal to x, and then the rest sine x dx is equal to dv. U equal to x, you can get du equal to dx here, and then if you integrate this, integrate sine, you get negative cos. So we can substitute this information inside the formula. Okay, so your u, okay, v is this part, v du, and don't forget the integration. And this is the minus uv minus v du. Okay, so from here you get this result, negative cos x. After integrate for this part, you get negative sine, and then negative multiplied with negative here, you get positive. So you get this result, and don't forget your constant. So how if we let the u equal to sine x for this case? So in this case, we let the u equal to sine x, where dv equal to x dx, and then integrate the v, okay, you get s squared over 2. Differentiate the sine x, you get cos x dx. So we substitute this into the formula. So this is your u sine x, this is your v, which is s squared over 2, and this is your du. So from here, you see that this function becomes more complicated, where the origin function is x sine x. Now it becomes more complicated, x squared over 2 cos x. So we do not recommend you to continue integrate by using the integration by part. So if you found this case, or you get problem like this, where you cannot get the result, try to choose the u, okay, instead of sine x, you choose the u to be the x, and solve it accordingly. In general, a proper substitution is very important for the integration by part. As you can see, one way may get the answer, another way may not. Sometimes, both ways can get the answer, but one way will be much easier than the other. Let's try with another example. We have a problem here to integrate the x ln x. So in this case, we have two functions, and this function cannot be solved directly using the best integration rule. And these two functions is the product of two basic functions. Therefore, we can use the integration by part. In this case, we let the u to be x and dv to be ln x. Where you can see integrate the ln x will be much more difficult where you get the result in this. So we apply this information inside uv minus v du formula. So uv minus v du here. Okay, so we can multiply it inside, we get this answer. Multiply here, we get another answer here. So minus remain, x ln x is unknown, so we remain here. So integrate negative x, we get negative x squared plus 2 over 2 here. So we can bring this function to our left hand side. Therefore, we can have 2 integrate x ln x function equal to the remaining. And then we can divide everything by 2. So you can see that the c, okay, here is for any constant, so we don't need to divide it by 2. As if let's say the initial is c1, okay, if you have c1 over 2 here, c1 divided by 2 here is still equal to c2, which is a new constant c. So to make it simple, you can just write c. In this case, you can see that the ln x is much difficult to integrate to get this answer. It is preferred to choose it as u. So how if we let u equal to ln x? Let's try. So for the same problem, we let the u equal to ln x. We differentiate it, we get du equal to 1 over x multiplied dx. Then we let the dv equal to x dx here. And we integrate it, we easily can get x squared over 2. Then we substitute this in the formula uv minus v du. For this part, okay, we can rearrange to this answer and integrate x squared over 2 divided by x. Here we get integrate x over 2 dx, right, which is this answer. And then integrate this, we get x squared over 2, okay, 2 multiplied 2 at the bottom, therefore we get this answer. And don't forget the c. So it seems that this method, if you choose a correct u, you can solve the problem in a much easier way. So both substitution, either you choose u equal to ln x or u equal to x, both are working well, but this one is much easier. This is example 3a. We have to solve this problem, integrate exponential x multiplied with sine 2x. Same observation, we cannot solve it easily by using basic integration rule. And then the integration is in the function of multiplication between two basic functions. We have an exponential and sine function here. So in this case, we try to use integration by part. So let's choose the u to be ex, and then your dv will be equal to sine 2x dx. Okay, we differentiate, we get dx as well. And then dv, we want to obtain the v, we have to do the integration. Integrate sine 2x, you get negative cos 2x. And then don't forget, you have to divide the constant, okay? The constant 2 is obtained by differentiate 2x inside. So you differentiate 2x, you get 2 here. So we can substitute this inside the formula uv minus v du. And this part, when we multiply, we get this term. And you have to integrate this function. So from here, negative, you get positive. So the remaining integration is quite complicated because you have two products between cos function and exponential function. So what we can do is we continue the integration by part. Okay, this part, okay, this integration, we continue with the integration by part method. So in this case, same, we choose u equal to ex, dv equal to, in this case, cos 2x dx. So you get du equal to ex dx, dv equal to this cos 2x dx. So you have to do the integration. After you integrate, you should get sine 2x divided by 2. And then you substitute this into the uv minus v du formula, and you get this result. So this result is for this integral part only. So after you substitute this inside, okay, we can form a new equation here. And from this equation, you can see that although we cannot solve integration ex sine 2x here, but we can bring it to the left hand side. To do this, we have to multiply 1 over 2 inside the bracket as well. So this one multiply here, and multiply with this, we get 1 over 4. Okay, after you multiply, you should get this answer. So, and you move 1 over 4, this integration part, to the left hand side. So it becomes positive, plus 1 over 4. So 1 over 4 plus 1 here, okay, in total you get 5 over 4. So multiply both sides with 4 or 5 to cancel this factor. So on the left hand side, this can cancel, equal to 1. And on the right hand side, you have to multiply with 4 over 5. So 4 over 5 multiply the first coefficient, negative 1 over 2 here. Then you can get 2, negative 2 over 5, which is this term. 4 over 5 multiply 1 over 4 here, you get 1 over 5, which is this term, right? And the remaining, you should write a constant here. In this example, we show you that sometimes we need to perform integration by part twice. So in this case, this is the first time we apply integration by part. Okay, and then we get something in integrate cos exponential, and this term we continue to solve it using integration by part. So this is the second time we apply it, and then we get the answer which is same with the original problem. And lastly, we can rearrange it to obtain the final answer. So this is our method, okay, to solve this problem. So in this case, how if we let the u equal to sine 2x? So instead of having u equal to ex here, we let the u equal to sine 2x, right? So this is an important remark for you to remember. Let's continue. For the same problem, in this case, we let the u equal to sine 2x, then your dv will be equal to exponential x dx. There's a typo here. Okay, we have correct the typo. So let's continue. We substitute the uv du dv inside the formula. Okay, we get this. So these two terms multiply together. Okay, we get back this term minus with exponential x cos 2x, where your constant 2 can be bring forward. Then we can see that for this term, is a product, right, between exponential and cos. So we can use the integration by part to solve it. In this case, we choose the u equal to cos 2x, let the dv equal to exponential x dx. So you integrate the dv, you get the v, which is dx. You integrate cos 2x, you get sine 2x. Okay, don't forget the negative 2, which is you have to differentiate the 2x inside. And you differentiate cos, get the negative sign. So after that, you substitute inside the uv minus v du formula here. Then you get this term. So what we are solving here is the integration by part for this term. So on our right hand side, you can see that we have this sign, which is exactly the same with the original function. Okay, so this term will remain, and the constant bring forward you get plus 2. So we can substitute this equation inside this term, then we get this equation. Then we can multiply the 2 inside for the bracket. So 2 becomes 4 here. Since this term and on our left hand side is the same, so I can bring this to the left hand side. So 4 plus 1, I get 5 here. Because here is a negative, don't forget, this is negative 2, negative 4. Okay, you bring to the left hand side, you get 5. And then let's divide this. Then you have to divide all by 5. So the first term you get something in 1 over 5 exponential x sine 2x. Second term you get negative 2 over 5 exponential x cos 2x. Right? And don't forget they're all constant. So this is our final answer. So you see that for this case you get the same answer like the previous method, where you need the integration by part for two operations. Okay, one operation here, another operation is here. So with that, we have finished make the revision for the integration by part.